Hello students, welcome back. Let's resume our discussion. Previously, we went through the mathematical structure of hypotheses, and then we practiced setting up the hypotheses with this example problem. One more. Okay, here's another problem, a little bit longer and thus a little bit harder. Please stop the playback and read through. So what do we have here? We have mean birth weight of babies born in the United States, 3,300 grams, and then mean birth weight for women living in poverty, 2,800. And then local hospital introduced an innovative new parental care program, and we got 3,060 grams. Okay, we have all these numbers. How do we set up appropriate hypotheses? The final question here is, has there been a significant improvement in the birth weight of babies born to poor women? Based upon that, set up appropriate hypothesis. Well, all right. Let's begin. Null hypothesis and alternative hypothesis. The mean is about, we have a problem. We have several competing numbers. 3,300 grams, 2,800 grams, 360 grams. Which is it? I don't think there is anybody who would get confused with 500 grams or 20 among all these numbers, so I remove those. 500 grams, that's a standard deviation, so that's not what we are interested in for now. And 20 randomly selected babies, that's a sample size, so that's not associated to the mean. Mu can be either any of these three numbers. Which is it? The population mean, the total mean of all babies here that we are interested in. At first glance, it looks like 3,300 grams because it's a mean weight for all United States. But this is a big but, really big but. However, look at this problem here. Has there been a significant improvement in the birth weight of babies born to poor women? This problem and this parental care program is all about poor women. And use your common sense. Would you rather use tax money to improve babies' health for everybody, including affluent people or middle class, upper middle class family, who will do their own by themselves with their own expenses anyway? I mean, helping babies, oh, that's great, but we have only limited resources, so we have to focus upon the babies coming out of poor family. That is our focus of attention, and that population mean is the one that we are interested in here. And that value is not 3,300, it's 2,800. This one. Does it make sense? Women living in poverty is 2,800 grams with standard deviation of 500 grams. Okay, with the standard deviation, that could be additional hint, but this can be easily knocked off because I could have given another standard deviation here along with 3,300 grams there. So that's not really the important part. The key part is in poverty. So we are talking about born to poor women. And then with all these things, they're all about babies coming from women living in poverty. It's all about that. And finally, 3,060 grams, that's coming from the sample. Null means null. Null means none, no. So it should come out of nowhere, not from the sample. So we conclude the number we want, the null value, is 2,800 grams. Now, how about alternative hypothesis? By now, everybody will understand that we need inequality. So, okay, is it greater or less? It's greater. How do I know this is greater? Number one indicator, we want improvement. Improvement in baby's health at birth. And that translates to bigger birth weight, okay? With more nutrition and more development, we have babies with more weight. If you do something similar to elderly people or middle-aged people, say about diabetes or things like those, in that case, overweight is a problem. So improvement there will be associated to less weight or weight loss. But here, improvement is associated to higher weight. So you have to read through. The problem did not explicitly say increase in birth weight, but you should see through it. Improvement here means bigger birth weight. Also, there's another indicator. Sample mean was 3,060. That's much bigger than 2,800, right? Okay, so all right. Oh, I did something wrong. Bigger than 3,060. What am I doing here? These two numbers have to be the same. Okay, all right, that's right. Yeah, I was kind of setting up a trap equal to 3,060 as I did in previous example, but I decided not to, but did not bother changing this mu0 value. This value and that value must be the same, and equal here and then inequality there. And direction of the inequality is associated to the context, number one, and also the sample mean. Okay, that's how you set up. And here is a visualization associated to that. So 2,800. And then how big an improvement is considered as large enough? Well, we're looking for the threshold. And the 3,060, if it falls here in the blue region, that means too close to null. So null hypothesis wins. So we're going to accept null hypothesis, not enough change. But as you see in this case, it went to the red region, so far away from the null. So I'm going to reject null hypothesis and accept alternative hypothesis. Yes, mean birth weight increased. So we have sufficient evidence to declare that this new parental care program did help improving the newborn baby's health. Let's see, we have one more example problem here. And this is really bad example problem. And part of the reason I wrote this problem is because how bad can this usually be? Here we go. In the previous problem about the babies, set up the hypothesis based upon this question. Is there sufficient evidence to declare that the new parental care program made a difference? What do you mean by made a difference? Can we take it literally and difference is mathematical difference? Or made a difference as make an improvement, kind of rhetorical kind of expression, alternative expression? Well, it's quite ambiguous, isn't it? All the more reason this is not really appropriate once you step outside of the classroom. In classroom, you can consider it, but that's about it. I don't know how useful this is outside, so I'm not going to emphasize it very much. All right, so much for all the examples. And even though I have one more topic here, 1.6, I'm going to stop here and shift it over to the next video. And the next video will be an optional video. We're going to talk about something highly theoretical.